Hi, welcome to the Calculus 1 lecture series. And we are in the lecture number 14. And we're still in the units, still in the unit number 2, the derivatives. So for this lecture, we're going to talk about some applications, especially in the natural and the social sciences area, and take a look at what is the rate of the changes here. Okay, and so basically for this lecture, we're going to kind of try to use some real life example, try to interpret of a derivative as an instantaneous rate of the changes here. Okay, so we're going to do a few examples to show you what's that mean. Okay, so let's go ahead and go to our lecture handout. Okay, so the first thing here, so basically we have the different social science, natural science example. So in here, remember the keyword here is the derivative as instantaneous rate of the changes here. Okay, so there are a couple, especially in the calculus one of the most commonly used is the we call the the relation of the position function, velocity, and the accelerations here. All right. So let's take a look here. So with the first ones here, we call this the position functions. So sometimes, most likely, we use the notations here is st. Okay, that means that you have some object or particle traveling around. So where it stopped at the time t here, all right? So that's why we use the variable t. That means after certain time where you stopped, right? So for example, if you're traveling from here, if this is your starting point, okay, then you go boom, boom, boom here. So then maybe during this time, you forget something, you go back here to take it, and then you go here again, then you forget to pick up friends, you back here. So here, this is where you stopped after the t, like t minutes, so t seconds, depends, right? So it's where, so where is here, right? So that's what we call this position function. So they are, the next ones here, the after position function we want to see is the velocity function. Okay, so velocity function, that is in here, we said the velocity function, we typically use VT to represent, and that will be the change, is S prime T, is the derivative. That's why we saw the velocity is the instantaneous rate of changes here. So like what's that mean? That means like this example, you go back and forth to kind of try to find your friends, right? So like you're driving here, so you go this way first, and then you go back, and then you go back, and then you go back here again. So finally, this is at the time t, for example, 5 minutes here. Okay, so what is velocity? So velocity, that means at this moment, for example, at this moment, right? How fast you go. Right? So if since you travel on a line here, so if you travel on a line, if your particle travel on a line, then we know the velocity, if it's greater than 0, that means I'm going forward. Right? So if your velocity is less than 0, that means I'm going backward. So like this example, like when you travel, when you start the point, you go this way, right? You go this way. Then at right at this moment, you look your car to see how fast it goes. So this is your velocities, right? So at that moment, so because you travel forward, you will get a negative, positive numbers, right? Now in here, then after you reach this point, you go backward. Then if you look at your speed here, then you see a speed here. That means this one's here is what? You will get a negative velocities here, right? So you will get a negative velocities here. Okay, so that's the value of the negative velocities here. Okay, so that's what is the velocity function. It's a change in the locations, right? So it's an instantaneous changes. Now, the next thing here is in the calculus, one word we use the most frequently, we call it acceleration. Okay, so it's acceleration functions here. So what is the acceleration function? We use AT here, right? So AT is the derivative of the VT. So it's a change of the velocities. Okay, so like if your AT is here, right? So if you get AT positive, that means you're getting faster and faster and faster, right? So that means you, if you are driving a car, let's use the example, if you're driving a car, that means what? You are pushing what? The gas pedal, correct? Okay, so now if you go forward, and then if your velocity is less, your acceleration is less than 0, that means what you hear? Ha, you are pushing the brake, right? So you're pushing the brake, so you try to slow down here, right? So this is what we call the acceleration, the second derivative, right? So it's the second derivative for the position. So it's the first derivative of the VT. So acceleration is a change of the velocity. Velocity is the change of the positions here. Okay, so like I said in here, with one of the most used frequently when we talk about it is the position, velocity, and the acceleration. Okay, so now let's take a look here. They say the water is flowing out of the tank in such a fashion that after 10 minutes, they are 10,000 minus 10t minus t3 liters of water remaining. How fast the water flowing after the 2 minutes? So you see the word how fast, right? So let's me, what is the rate at 2 minutes? Just similar like you're driving a car, at 2 minutes, you look your speed to see how fast, right? So the same things here, you let the water, flow out, right? So it's similar like this is the, instead of the, so in here, I will prefer not confusing here, right? So I will say this is my volumes, right? It's not the velocities, right? So my volume at t is this 10,000 minus 10t minus t cubed, right? I want to find how fast, that means the rate of the changes, right? So the rate of the volume changes. So what I do here, I say volume t, take the derivatives, right? So when I take the derivative, these constants disappear. So I have a negative 10, then negative 3t what? 3t squares, right? So this is the rate of what? Of the volumes, right? Volume changes here. That means how fast it is flowing out. Then they say is the volume, how much the volume changes here at t is equal to 2. So it's negative 10 minus 3. The t is equal to 2 here. And what do you have here? You have negative 22, right? Liter. Okay, so the liter per minute. So you see here, right? So these ones here, we have a negative sign. That means water what? That means water flowing out, right? So if you have a positive sign, that means you keep adding the water to this tank, then water going to increase, the volume going to increase, right? Then you are going to get the positive rate of the changes here. All right, okay. So let's take a look at the problem number 2, see here. So the number 2, let's say a rocket is, so it's 16t plus t cubed meters after its launch pad, t seconds after liftoff. What is the velocity? So this one's here, I know this is the, what is the height meter, right? So that's what you can treat it as a position function. So it's a st after, the t seconds here, this is 16t plus t3, right? And if you put a so let's make sure we understand that, right? So if you put S3, okay, so if you put the S3, so this will be 48 plus what? 27, right? So what is this? You got a 75, correct? So this one is the meters. That means after 3 seconds, the rocket is at 75-meter high. All right, but they want to find the velocity here. So here they want to find the velocity after 3 seconds. So what we should do? We should take the derivatives, right? So that's the rate of the change of your height. So this will be 16 plus 3t squared. You get that? Okay, so now in here you just plus 16. So S prime 3 will just be 16 plus 3 times 3 to the square. So this is 27 plus 14. So it's 43 minutes per second. That means at the height of the 75 meters, what is the speed of that rocket at the 75 meters high is 43 minutes per second. All right, so at that point, this rocket traveled at 43 minutes per second here. Okay, now let's take a look at part number 3 here. So the number 3 is saying, a particle is moving axis, so at time t, this is a position function. What is the velocity at 3 seconds? Okay, so this is, we did it many times. So this is a position function, is t cubed minus 6t squared plus 6, right? So if you plug in the F3, that means it's where, how much you already travel at 3 seconds here, right? So now I want to find the velocity, so I take the derivative. So this is 3t squared minus 12t, correct? Okay, so 3t squared minus 12t. So now you plug in the f prime 3. So what is here is 3 times the 3 squared minus 12 times 3. So this is the 36. And this is the 27. So this is minus 9m. Okay. So the per seconds here. So what's that means here? So that's what is the part B asks you. Yes, they said that it's a particle moving left or right at 3 seconds. Because here what? Because this is negative. That means I know what here? I know my particle is moving left, right? So because that means your particle is moving left at the 3 seconds. Because why? It's because the f prime 3 is equal to the negative 9 meters per second. Okay. Okay. So now the part C, it tell you what time this particle is motionless. What's that mean? That means this is motionless. So what's that mean? The motionless, that means what? The velocity is what? Equal to 0, right? I'm not moving. Like when you drive your car, you go to right or go to left. Then at that moment, my car stopped, right? So for example, I stopped at a traffic light. So I'm not moving here. So we say what time this particle is not moving. So I know the f prime t is equal to what? The f prime t is equal to the 3t squared minus 12t here, right? So I want to find the time. I know the motionless is this one is equal to 0. That means the velocity, right? Because f prime t is the velocity. So now I will solve it. So you say 3t, and this is t minus 4, okay? Now this is equal to 0. So what's that mean? That means this is equal to 0. This is equal to 0, right? So the t is equal to 0 and t equal to 4. So we know t is equal to 0. That means at the beginning, right? That means I'm ready to start. I'm just sitting there ready to go, right? Then at the t equal to 4 seconds here, my particle become motionless also, okay? That means at t equal to 4, my car stopped, okay? All right, now let's take a look at the, this one is a very, very common, very common, and people, talk about this type of the things in the calculus. They say a stone is throwing upward, so that means I'm throwing this stone upward and off a cliff. Okay, so the cliff is 70 meters. And so the height above the ground. So this is my position functions, right? So this is 7t plus 3t minus t squared. This is how tall is the particles, right? Like this here. So this is the distance of the particles here. So if after a certain number of the time here, at this one, at this one, those are the, where is the positions, right? So they want to see what is the velocity, right? So of the stone hit the ground. What means the stone hit the ground here? The stone, this is the height, right? So this is the height above the ground. So when the stone hit the ground, what's that mean? That means this function is equal to what? It's equal to 0, right? Because f, this is what? This is, we call it a position function, right? So that means the position is right in here at the 0, see here, correct? All right, so now you will have 70 plus 3t minus t squared equal to 0. Okay, so if you factor, you can factor, this will become t minus, so if you factor, let's see here. Okay, so this one's here, it will give you, so factor, I factor here is 10 minus t and 7 plus t. That's right. Okay, equal to 0. So I know I set this equal to 0, this equal to 0, right? So this is t equal to 10, this is t equal to negative 7. I know I can never have negative numbers on my time. So this is now. Okay, so here, this is t equal to 10. That means after the 10 seconds, it will hit the ground. Okay, now I want to see how fast when it hit the ground. So how fast, that means the velocity, right? So I will say f prime t, right? So let's try to take the derivative. So it's 3 minus 2t, right? So we say at the t equal to 10, right? So when the t equal to 10, it will hit the ground. That's why I want to find how fast the speed. So I say f of the 10, this is 3 minus 2 times 10. So it's 3 minus what is 20, right? So this is going to negative 17 meters per second. Yeah. Okay, the reason why this is a negative, okay, so we have a different interpretations, right? So here this is the negative. That means because we cannot treat this as like axis, right? So when the particle go up, so we say this velocity here is what? The velocity here is the positive. Then when the particle start going down, go this direction, then this velocity here is what? With the negative. So like in here, when you're throwing something into the sky and coming back, so if you see a negative velocity function. That means this particle is travel downward. So it's similar like if you travel on a line, right? So if you travel, if you travel on the lines here, right? So we did the other one, we did the same one, similar one like the previous one. So if you travel this way and travel this way, right? So this is velocity going to be positive. This is velocity going to be negative. Or you travel up or you travel down, right? So you travel up, you're going to have a positive velocity. When you travel down, you're going to have negative velocities here. All right. Okay, so that's it. It's a very simple lecture and a very simple section, but we do have some very, very interesting problems to work on, right? So make sure you understand that, right? So we have the three things here. The velocity is the change of the positions, right? So velocity could be positive, could be negative. Then acceleration function is the change of the velocities here. Okay. All right, that's it. It's a very it's an interesting sections, and so the hope you like this section and will be able to apply it in your physics applications here. All right, that's it, and then I talk to you in our next lecture. We're going to talk about some other application as well. All right, that's it, and nice to talk to you. Okay, bye.